This is 6.4. We are solving problems now using quadratic equations. So we've learned all of the skills, or most of the skills now, to deal with quadratics. Now we're going to start getting into the actual problems that we're able to solve using these skills, right? Okay, so the first question says the x-coordinate of the vertex of a parabola x, 3x squared plus 12x plus 15 is x equals -2. So the little v down here represents vertex. It says determine the equation of the axis of symmetry and y coordinate of the vertex. So who can tell me? Very, very easy here, not a trick question. What is the equation for the axis of symmetry? Come on, everybody's hand up. Everyone's hand up. What is the equation for the axis of symmetry? We know the x value of the vertex. Jadane? It should be coming around. I don't know who had it last. Who had 6.4 last? There was the stapler coming around with the handout, 6.4. Where did it end? Where?
Stapler's over there, but I don't know where the handout is.
Who had the handout last? 6.4. Everyone seems to have the handout. You gotta go to the attendance office. Take off your sweater. Don't walk in my class with a sweater. What is it? It's your pants?
Yeah.
Why?
I ordered it.
Oh, okay. Sorry. You can go to attendance office. Are those the handouts? Okay, he needs one. Yeah, go ahead. Yeah. The axis of symmetry is what, Jafet?
X equals -2.
Yes, x equals -2. If we know the x-axis, sorry, the x-coordinate of the vertex, if this is the x-coordinate of the vertex, that is also the axis of symmetry. Okay? Very simple. Then it says, determine the y-coordinate of the vertex. So there's a couple ways we can do this, right? One way is we could convert this into vertex form, and we'd see the y right away, right? The other way is we could factor this. We could get the two zeros, and then we could find the middle term between those two zeros, the x value, which we already have, right? So we wouldn't do it that way. And then what do we do with that? To get the y-coordinate of the vertex, Rudy, when we have the x-coordinate of the vertex, what do? Yeah, you sub it in. Yeah, this goes in for the x here and the x here. Okay, so if we do that, we get y equals (3), right?
Yeah.
Okay, so y is equal to 3. Therefore, our vertex is -2, 3. Any questions? Max, you got to go to the attendance office. Why are you late?
I used the washroom like before.
So you, between classes, you went to the washroom and then came to my class 10 minutes late.
You said we can use the washroom.
Yeah, that doesn't mean you can come to the class 10 minutes late.
Okay. I'll do it later.
Thank you. Okay, next example, 2. The values x equals -3 and x equals 7 are the zeros of the quadratic relation. Determine the equation of the axis of symmetry and coordinates of the vertex. So, if we find the coordinates of the vertex, we're also finding the equation of the axis of symmetry, right? It's just the x-coordinate. Okay? So we want to find the vertex here, really. That's h and k. Right? If we know that the values x and x2 are the zeros, how can we find the x value of the vertex if those two are the zeros? Yeah, no kids? Yeah, you add them together. So h, there's actually a formula for this, right? H is equal to x1 plus x2 divided by 2. Those are the zeros. We know that because if you have two zeros, you add those two together and divide by 2, you're going to get the middle point, and that will be the x-coordinate of your vertex and the axis of symmetry. So this is going to be equal to -3 plus 7 divided by 2. We get 4 over 2, which is 2. So our axis of symmetry then is what? Yeah, how would you write it? RC? Sorry? What is the axis of symmetry? If this is the x-coordinate of the vertex, what's the axis of symmetry? Sorry? No, it's just this, right? I said it over here. It's the same thing. X equals 2. I'm not trying to trick you. That's the axis of symmetry. Well, if that's the axis of symmetry and the x-coordinate of the vertex, how do we find the y-coordinate of the vertex? Yep. Yeah, you sub it in. Same thing as example 1, right? So we're going to sub in wherever we see x, we're going to sub in a 2. So y is equal to -0.25, 2 squared plus 2 plus 5.25. So your vertex is okay? Any questions? All right. Example 3. Determine the equation of the axis of symmetry and coordinates of the vertex of a parabola y equals -2x squared plus 3x minus 4. So it doesn't tell us anything about the zeros this time. It doesn't tell us the x-axis of the vertex. What do you think we can do? What's the vertex? So what can we do?
You can factor it.
We could factor it, yeah. And that would give us the x-axis of the vertex. And then we could sub that in. There's a faster way that we just learned in 6.2. We want to do what? Yeah.
Minus b divided by 2a.
Minus b divided by 2a. You're right. That's a bit of a shortcut here. That's the x value of the vertex, right?
Yeah.
Yeah, and then you could get that and sub it in. You're right. You could do it that way. It's probably the easiest way. So x value of the vertex is equal to minus b over 2a, which is -3 over 2 times -2 equals 3 over 4. And then we could sub that in to get the vertex. The other way we could do it, right, is to complete the square for this. Now, I don't know if anybody spent a long time doing their homework, but they should be pretty comfortable with this. So the way we complete the square when we have an a value that's not 1 is we take the -2 right out from the beginning. Okay, we're going to divide out this -2 from the first two terms. So what we're left with is x squared plus, sorry, not plus, minus, because we're dividing by -2, minus 3 over 2x, okay? So all I've done there, that first step, is I've divided -2 from the first two terms. Does that make sense? Everyone okay with that? If you don't understand that, you're going to get lost quickly here. now I have these two values. What I want to do to make this a perfect square trinomial is I want to add half of this value squared. Right? So to 3 over 2, half of 3 over 2 is 3 over 4, right? 3 over 2 divided by 1/2 is the same thing as 3 over 2 times, sorry, not divided by half, divided by 2 is the same thing as 3 over 2 times 1 over 2. So you get 3 over 4, right? So 3 over 2 divided by 2 is 3 over 4. Does that make sense? Okay, now I need to square it. So 3 over 2 divided by 2 is 3 over 4 squared. That's the number I need. So 3 over 4 squared is 9 over 16. It's all in the margins here. So I'm going to add 9 over 16, and I'm going to subtract 9 over 16 because I cannot just add numbers to one side. I need to add 0. And then now I'm going to close off that bracket, and I'm going to leave the minus 4 on the outside. Any questions here? All right, next step. I need to make this a perfect square trinomial. Right now, it's a polynomial because we have 4 terms. So I need to get rid of this last term. So I need to multiply it by the -2 to release it from the brackets. That's how it works. So the way we do that is we leave the -2 here for all the other terms. And the -9 over 16 becomes positive because we're multiplying it by -2. 18 over 16 minus 4. Okay, next step now. This is a perfect square trinomial. Why? Because I created it. I'm going to have this. And this is 4 is the same thing, right? We need to find a common denominator, so we need to multiply this by 16, right? To get 16 over 4. Sorry, to get 4 over 16, so we need a common denominator here, so we have 18 over 16 minus 4 times 16. Is that 64? Actually, let's work with smaller numbers. We'll reduce this 18 over 16. We'll cut it in half, so we got 9 over 8. Now we just have, we have to multiply the 4 times 8 to get 32 over 4. So 9 minus 32 gives us 23, and it's going to be negative. So we're left with negative 23 over 8. And you could do that on your calculator, right? 9 over 8 minus 4 is negative 23 over 8. So our vertex then, this is in vertex form, is just h and k. H is, remember, the opposite sign here. So not negative 3 over 4, but positive 3 over 4. And now the k value is the same, negative 23 over 8. Okay, so vertex form gives us that. Using this method, we got 3 over 4. We would have had to sub in the 3 over 4 into this equation, and that would have given us the y value of negative 23 over 8 as well. You could have done it either way.
So which one's easier?
To get the x value, I would have said that this way, but you need to know how to use both.
Yeah,
Okay? All right, example 4. Sketch negative 2x squared plus 4x plus 8. All right? So the x value, here we can use our shortcut here to get the x value of the vertex, which we know is negative b over 2a. Okay? Here's b is 4, so negative 4 over 2, and a is negative 2. So we actually get 1. It's going to be negative 4 divided by negative 4 is 1. So that's the x value of our vertex. x coordinate of the vertex is 1 right here. Determine the y coordinate of the vertex. So we're going to take that 1 and we'll sub it in for x here and here. And we get y equals negative y is equal to 10. Okay, so our vertex is 1, 10 all the way up here. 1, 10. Okay, determine the step pattern. So the step pattern we know is 1, 3, 5. In this case, its a value is negative 2. It's actually 1a, 3a, and 5a, right? So our step pattern is going to be negative 2, negative 6, and negative 10. We're just multiplying each one of these by a negative 2, right? Okay, so that means we go over 1, down 2. Okay, that's our step pattern. Over 1, down 6. 1, 2, 3, 4, 5, 6. And over 1, down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry? We mirror those results and we get our parabola. It says determine the y-intercept. So that's the point at where it crosses the y-axis. You can see here it's right on at 8. Okay, so that's basically when x equals 0. If we sub in x equals 0 to the equation, we get y equals 8. That's our y-intercept. Any questions? Okay. Example 5. For each parabola, determine an equation from the graph in standard, vertex, and, if possible, factored form. So what does it mean, if possible? Why does it only say if possible for factored form? Who can tell me why? Maxis. Yeah, what times? You're right. Sometimes you can't put it in factored form. Why not? Asian. Sorry? Yeah, when you're factoring algebraically, but I'm wondering what's going on in the graph when that happens. Yeah,
Nothing touches the x-axis.
Yeah, nothing touches the x-axis. So if here's the x-axis and here's the y, for the parabolas that do this, they open up above the x-axis or they open down below the x-axis. They don't have zeros. Sorry, they don't have zeros, these two, because they never touch the x-axis. They'll still have a vertex, so we'll still have vertex form. They still have standard form, but they don't have zeros. They don't cross the x-axis like these ones. All right? So these two, I can see they all have factored form. Okay, so we're taking the graph now, we're going the opposite way. We're taking this graph and we're trying to develop the formulas. Okay? So let's start with the one on the left here. Okay? So we know that our vertex form, it's the first one we want to do. So y is equal to, we know vertex form looks like this. Okay? We know that by definition. What do we know about this equation from this graph? Yeah, Andrew.
The points of the vertex.
Yes. Which is?
-4 plus 3.
-4 and, no, -3, right?
Yeah, -4 and -3.
Okay, so I can take those two values now and sub it in, right, for h and k. So I get y equals ax plus 4. Notice how the sign is opposite of the vertex sign for the x coordinate. And then the k sign is the same. So the only unknown I have here now is the variable a. So what can I do to solve for a? Anybody know? I haven't covered this, so I'll tell you. You can just take any point that is on the actual parabola, sub it in for y and x, and solve for a. That will give us a. Alternatively, you could try to figure out the step pattern, but we can see already here that it's not in round numbers. 1 over, you can't see how much it's up. You can see that it's going to be a compression. It's going to be a fraction. But the way to find it is we need to take a point on the parabola and sub in to the equation. Okay, so let's take an easy point that includes a 0. We'll take one of the ones that crosses right through the x-axis. So looks like we can take this one. It's even called out, right? 0, 5. Okay, so let's sub point 0.05 into our newly developed formula for y and x. So y is 5, ax is 0. So we get 4 squared is 16, so we'll get 16a minus 3. 3 is going to come to the other side. We'll get 8 equals 16a. A is equal to 1/2. Okay? Dividing both sides by 16. Alright, so then if a is 1/2, we can sub that back into our original vertex form, and we get 0.5 x plus 4 squared minus 3. Any questions there? That's vertex form. Alright, how can we get standard form? Yeah. Anybody? Nobody? We can just take vertex form and expand it. What? Yeah, we have to expand this out, right? So we'll get standard form just by doing a little bit of math here. Okay, we're just now multiplying this out. Plus 4x plus 4x, so it's plus 8x plus 16 minus 3. Now we multiply everything by 0.5 in the brackets. There's our answer. That's standard form. Good? Any questions there? That's why we got vertex form first, so we could go ahead and get standard form. Last one we want to do is to get factored form. Okay, so how would we get factored form? We would need to factor this. So because we're already working with a decimal, the way we would factor this is to use what? How would we factor this? Can we use it doing the x? The magic x? We already have a decimal in there. Nobody remembers yesterday's lesson? Yep. No. We have to use the quadratic equation. We're in this one. This graph. Yeah. We're trying to find factored form. I mean, one way you could look at it and look at the intercepts here, which I think is negative. We don't know for sure though, right? Like if we looked here, we can see the two zeros. This looks negative 6.25 and this looks like negative 1.75. So if we had those, we could put it in factored form, right? Well, let's just do this. The way to confirm is you would have to use this formula. Okay, you'd have to use that formula and sub in the A value, the B value, the C value. But let's just say this is pretty clear. I think it is here. This is 1, right? This is 1 and 1.5. That's -2. So here, our factored form is x minus r, x minus s. Sorry, A at the beginning. We already have A, so we're going to say A is 0.5 x minus r, so this is a negative number, so it's going to be plus. It's going to be 6.25 and x plus 1.5. That's our factored form. Okay? And you can check that by finding two values of x here by using this formula. Let's do the other part. I'll roll it down here on the bottom. Here we don't know the vertex. It looks like we do up here, but it's not called out specifically like it was here, so let's assume we don't know it. We have to start with the x-intercepts here, and they give us a point. Okay, so let's start with factored form. We'll say y equals a x minus r, x minus s. A in this case, we don't know yet. X minus 0.5, x minus 4.5. All right, now to get the A value the same way, we would sub in a y and x value. In this case, we're going to use 4 and 3.5 because those are that's the only value that's been called out. So I would say 3.5 equals A 4 minus 0.5 and 4 minus 4.5. So we have 3.5 equals A 3.5 negative 0.5. A 3.5 times negative 0.5. What's that? 1.75? Negative 1.75. A. I think someone want to confirm that with their calculator. 3.5 times negative 0.5. Okay, and now do 3.5 divided by negative 1.75. Negative 2? Even? Okay. So that's our A value. We can confirm that here, right? If we look at the graph, so what we're saying is if we go 1 over, we're going to go down 2. So 1 over, remember these are 0.5s. So we got to go 1 over, we got to go 2. So, and then down 2 would be 4. 1, 2, 3, 4. It looks like that's correct. Right? 1 over. And then 2 down. So we can see the A value is negative 2. So there's our factored form. Y equals negative 2, x minus 0.5, x minus 4.5. That's our factored form. Okay? Now to get vertex form, or to get standard form, we could multiply this all out, right? So we're going to have negative 2, and then we get x squared minus 4.5x minus 0.5x plus 2.25. Minus 4.5 minus 0.5 is minus 5x. There's our standard form.
Yes, sir.
Yep.
Where's vertex?
Vertex form? We haven't got it yet. We're going to get it now. So vertex form, we need to complete the square. So the way we would do that is we divide the first term, two terms by negative 2. You're left with x squared plus 5x. Now we want to add half of this value squared. So it would be 5 divided by 2 squared. So it would be 5 over 2 squared, so 25 over 4. Minus 25 over 4, and then minus 4.5 on the outside. To release this last term, you need to multiply it by the 2 so it can go out of the brackets. So we're left with negative 2. Let's perfect square this. Plus 5 over 2 squared, and then this becomes positive 50 over 4, right? Negative 2 times negative 25 minus 4.5. So I just need some help with 50 over 4. What's that? Minus 4.5? I'm running out of space here. Is it 8?
8.
Yeah. So we're left with y equals negative 2 x plus 5 over 2 squared minus 8. Sorry, minus 8 or plus 8?
Just 8.
It's plus 8. Right? Because 50 over 4 is much higher than 4.5. So it's definitely plus 8. Any questions? Okay. Six. Okay, a parabola has a vertex at negative 3, 4 and passes through the point negative 1, 6. Determine its equation from the determine its equation in vertex, standard, and if possible, factored form. Okay.